Okay, everybody, we are going to finish up talking about irrational numbers real quick. Um, all classes we got to talk about rational, integer, whole, and natural numbers, but we never got to irrational, and I want to discuss that with you. Um, all of you guys did an amazing job talking about these and looking at the different types of rational numbers. We start with our most basic subset, which was our natural numbers. And then from our natural numbers, we went on to our whole numbers, and then our integers and our rational numbers. And we talked about how if a number is natural, that automatically makes it whole, integer, and rational. Okay, it is part of all the groups. If it starts at the bottom, it's part of all the ones that are greater than it. Now, so I could take any number in red, and I can put it in any one of these boxes, and it would work. It doesn't go the other way. For example, 1/8 is rational, but it is not an integer, a whole, or a natural number. Okay, but 4 is rational, integer, whole, and natural. You got to remember the different ways that they relate. So now we're going to talk about irrational numbers. So we said before that a rational number is any number that can be written as a fraction. So a decimal that repeats, which means it goes on forever with a pattern, or it terminates and stops. So we are going to look at that now, and we're going to look at irrational numbers. So my question to you is this. If a rational number is a number that is a decimal that repeats or terminates that can be written as a fraction, think about what an irrational number must be. And hopefully many of you have come to the conclusion that an irrational number would be any number that cannot be written as a fraction. So it's any number that cannot be written as a fraction. So what does that mean? Well, let's go into some detail about that. First of all, I want to make this bigger because it'll be easier to see, and I want all the fonts to match. And second of all, I want to make it more orangey because I don't like that orange. Let's do more orange. Okay, that's better. All right, so what does this mean for us? Well, this means that we are looking at special decimals here. We're looking at decimals, any decimal that does not repeat or does not terminate. So what kind of number is that? What kind of number is that? Well, that means we're looking for non-terminating. Well, basically, we're looking for a decimal that goes on and on forever, but never has a pattern, okay? And there's actually like a really, really, really famous number that's super popular that is irrational. And y'all might know, I know some people in my classes today mentioned that number. What is that number? Well, that is the number that's actually represented by the symbol pi. Pi is a really, really famous irrational number. Okay, it is a number that does not repeat, it does not terminate, it's never going to end. You could spend the rest of your life writing out the digits of pi. There's generators online that generate the first 10 million digits of pi. Okay, so just a few are the 3.14159. Those are the most common what digits we know, but it goes on forever. There's no pattern here, and it never stops. So that is an irrational number. Okay, so that's what we're looking at with irrational numbers. If you put your calculator and you see it goes on and on and on with no pattern, that means we can't write this as a fraction, and it doesn't stop and it doesn't repeat. So some examples of irrational numbers is obviously pi is our most famous example. Let me copy this and paste this. Oh, there we go. All right. So what are some other examples of irrational numbers? Well, you could always make up an example of an irrational number. Okay, so we can make up like -5.6718924001 and on and on and on and on. That's an example of an irrational number. But we actually have some irrational numbers that we're going to see a lot of. In first block, someone mentioned the square root of 64, okay? So the square root of 64 is 8. That works out. 8 is a natural number, it is a whole number, it is an integer, and it is a rational number, okay? So the square root of 64 is an 8. You guys know the square root of 4 is 2. The square root of 25 is 5. What about, though, if I gave you some other square roots? What if I gave you, for example, what if I gave you the square root, hold on, trying to get my design over here, the square root of 20. What if I gave you the square root of 20? What is the square root of 20? What's the square root of 20? Does anybody know? Well, you know what we can do? We probably don't know that off the top of our head because we're going to see something really interesting about that number. What we're going to do is we're going to take that number and I'm going to put it in my calculator. So if you have your calculator, you're going to grab it and we're going to put in the square root of 20. Okay? And if I get my calculator to work, hold on. Hold on, my dears. Hold on. Okay, so the square root of 20. Square root of 20 is a decimal 4.472135954995979, and it only stops there because my phone screen runs out. That would keep going forever. So that is irrational. It's the square root of 20 is an irrational number because it's a decimal that goes on forever without repeating. So let's try another one, okay? Let's try the square root of, see, this is why I wish I had you guys to respond to me and it wasn't recording because you could give me your awesome answers. Let's do the square root of 8. Let's do the square root of 8. What is the square root of 8, everybody? Well, put it in my calculator. The square root of 8 is 2 decimal place 8284271247469 ... It would keep going if my screen would keep going. Yet another irrational number, another decimal that does not repeat but also does not stop. Let's do one more. Let's do the square root of, let's do the square root of 5. Let's do the square root of 5. Square root of 5 here. So what is the square root of 5, everybody? Well, I grab my calculator. Square root of 5 is 2.2366797749979 ... Okay, yet another non-terminating, non-repeating decimal. Okay, so these are all examples of irrational numbers, and we can actually make a rule based on these square roots. And here's this rule. I want you to write this down. The square root of any non-perfect square is irrational. Okay, the square root of any non-perfect square is irrational. Okay, guys, so what does that mean? That means anytime I have a number that I can't take the perfect square of, it's an irrational number. It's going to be a decimal that does not repeat and does not terminate. And because these numbers do not repeat and they do not terminate, I cannot write any of these numbers as fractions, okay? That's one thing that makes me so mad is on state testing, they tell you to use 22/7 for pi. And I'm like, hello, we just spent a whole semester teaching kids that pi cannot be a fraction, and now you're telling them to use that as a fraction. What on earth, guys? It's crazy. So take a second and try these out. Make sure you understand it. One other thing I was going to talk to you about is, so what is the actual definition we're going to use for real numbers here? What is our definition for real numbers? Well, the definition I'm going to have you guys use for real numbers, oops, hold on, is right now, all numbers at this point are real numbers. So what does that mean? That means there are imaginary numbers out there. There are imaginary numbers out there. But guess what? We're in 8th grade and we don't need to learn about those imaginary numbers. They're out there, they exist, but we are not going to concern ourselves with them. We know they exist, but they are not going to be something we work with. I will talk to you a little bit more about those in person, but I want you to see here, every single number in this picture is a real number, okay? In fact, if I took a giant pen, okay? I took a giant pen and I erased all these lines, okay? I erased all these other color lines. I erased the integer line. I erased the pink rational number line. I know this is really bad, but I'll just go with it. Okay, I erased all these lines. All these lines are erased. Erase the orange line for irrational numbers. Okay, I erased the blue line for whole numbers. I erased the red lines for natural numbers. All of these numbers are inside the real numbers box. They all fit inside this purple box. Therefore, they are all real numbers. So it doesn't matter if it's rational or if it's irrational, they're all real. Now, what I would like you guys to do is take a second and make sure this is all copied, and you can obviously pause it. And then I want you guys, we were going to do this in class yesterday, but we didn't have time, to take a second and fill out this chart. So you would check all that apply. So what I'm going to do is I'm going to pause the video for a minute. I want you guys to pause the video for a minute, and I want you to come back after you've filled out which category these numbers belong in, okay? Okay, so let's go over these very quickly. So we have the categories natural, whole, integer, rational, irrational, or real. And we're going to go through, we're going to just check off which one it belongs to. So 15. 15, you should have gotten that 15 was a natural number. And since it's a natural number, that automatically makes it a whole number, an integer, and a rational number. Now, I want to stress this to you. You should never check rational and irrational at the exact same time, ever. Okay? You should never check those out at the same time because they are not going to be, if it's rational, it can't be irrational. Okay? So it's a natural, whole, integer, rational, and then it's real because all of the numbers you're looking at are real. In fact, you're going to see that every number on this list is going to be marked off as real. Okay, so if we choose natural, it's automatically the next three. All right, -1 and 232 thousandths. Okay, so it's a negative and a decimal. That means it's not natural, it's not whole, it's not, even though it's a negative, it's not an integer because integers don't have decimals. So it's just rational and real. And we know it's rational because it's a decimal that stops. It's a decimal that terminates. Okay, the square root of 45. The square root of 45. We don't know the square root of 45 off the top of our head. It's not a perfect square. So if we want to check it, we're going to put the square root of 45 in our calculator. All right, it's not a perfect square, so I already have a feeling I know what it's going to be. And when I get that, I get 6.708203932499369, on and on and on and on. So this is a non-perfect square. So this is an irrational number. It's a decimal that goes on forever without repeating or stopping. Not only if it's irrational, it's still real even though it's irrational. All right, 121 divided by 35. 121 divided by 35. You do need to check if you can simplify that. 121 does not divide evenly by 35, but it is a fraction, okay? So it's a fraction. It's a fraction. And we said this in my first walk class, and I love this, and I want to point this out to you, okay? In the word rational, we see the word ratio, okay? The word ratio, we see the word ratio. Ratio in math means a fraction. So if it's got a fraction, it's automatically a ratio. It's a fraction. It's rational. And it's also real. It can't be natural, whole, or integer because none of those have fractions in them. All right, the square root of -16. The square root of -16, we keep the negative on the outside, and we know the square root of 16 is 4. So we get -4. So I've got -4, but it can't be natural and it can't be whole because those two numbers aren't negative. It is an integer. It is rational because we can put it over a 1, and it also is real. And the last one is 21 divided by 3. You need to simplify this. 21 divided by 3 is 7. 7 is natural, whole, integer, rational, and real. Notice that every single one of these we checked off real numbers because they're all real. So that's everything you need to know about rational and irrational numbers. Make sure this is in your notebook. It is not going away. We're going to keep using it. If you waited to take your quiz, go ahead and try it after this, and good luck. Thanks for watching, everybody.